Hello, space fans and curious minds. Buckle up because we're about to take a fun, mind-blowing tour of our universe. We'll keep it light, conversational, and a little bit goofy because space is amazing, and it's okay to laugh while we learn. By the end of this 60-minute journey, you might just look up at the night sky with a whole new appreciation and a couple of chuckles. Ready? 3, 2, 1, lift off. Leaving Earth, our first step into space. Let's start right here on Earth, our cozy little home in the cosmos. You might feel like you're sitting still right now, but surprise, you're actually on a spaceship of sorts. Earth is zipping around the sun at about 67,000 miles per hour. Yes, 67,000. That's like going from New York to Los Angeles in under 3 minutes. Talk about a road trip. And you thought your commute was fast. Yet we don't feel a thing, because Mother Earth provides such a smooth ride. From a distance, our planet is just a pale blue dot floating in the darkness. In fact, when Voyager 1 spacecraft looked back from 4 billion miles away, it captured Earth as a tiny speck, a mote of dust suspended in a sunbeam, as Carl Sagan famously said. Everything we've ever known is on that speck. Kinda puts things in perspective, right? Don't worry, we're still significant. We're just tiny. But hey, good perfume comes in small bottles. Space, the final frontier, is actually closer than people think. There's no hard border, but a popular definition says you're in space at 100 kilometers up, about 62 miles, also called the Kármán line. That's it, just 62 miles up. If you could drive your car straight up, preferably one with wings, but humor me, you'd be in outer space in about 1 hour going highway speed. 1 hour. You spend longer than that in weekend traffic. Of course, driving straight up isn't actually possible. Gravity, pesky atmosphere, blah blah, which is why we use rockets. And rockets don't just go up, they go really fast sideways to orbit Earth. To stay in orbit, you need to whip around Earth at about 17,500 miles per hour, 28,000 kilometers per hour. Achieve that, and congratulations, you're an Earth satellite. Speaking of satellites, let's visit the International Space Station, ISS. It's our orbiting lab where astronauts hang out in microgravity and do TikTok trends in space, presumably. The ISS is about 250 miles above us, and it circles Earth every 90 minutes. Imagine seeing a sunrise or sunset every 45 minutes or so, because that's exactly what astronauts experience. They get 16 sunrises and 16 sunsets each day. Every 90 minutes, the sun comes up, then it sets again. Talk about frequent mood lighting changes. They have to pretend it's night by just dimming the cabin lights. If you've ever complained about one sunrise being too early, try 16 of them. Time to sleep? But the sun just rose? Again. Life in orbit is weird and wonderful. For one, there's no up or down. Astronauts float around like superheroes, or maybe clumsy acrobats at first. They can sleep on the ceiling if they want. Actually, they have to strap themselves into sleeping bags so they don't drift off and bonk into gadgets. And without gravity compressing your spine, guess what? Astronauts can become about 2 inches taller during their mission. Finally, a way to fix that slouch, just go to space. Their height returns to normal when back on Earth's surface, but it's a nice temporary confidence boost. I'm officially taller than my brother for now. Another quirky fact, space has a smell. Weird, right? In the vacuum of space itself, nobody can smell anything, and no one can hear you scream, but that's another story. However, when astronauts come inside after a spacewalk and take off their helmets, they report a strong odor clinging to their suit. They've described it as metallic, like gunpowder or burnt steak. One astronaut called it a really, really strong metallic smell. The smell of space. Imagine a mix of gunpowder, hot metal, and barbecue. That's the scent of the cosmos on your clothes. Kinda badass, right? It's like they've been out welding the universe. Maybe Calvin Klein's next perfume should be Ode to Spacewalk. Now, floating around in microgravity is fun until nature calls. What do you do if you're literally in the middle of space and need a bathroom? Answer, you use the MAG. NASA's got acronyms for everything. This one stands for Maximum Absorbency Garment, which is a polite way of saying space diaper. Yes, astronauts wear diapers during spacewalks. A spacewalk can last 6 to 8 hours, and there's no restroom up there on the ISS roof. So astronauts just gotta go with the flow, in the most dignified high-tech way possible. The mag is a super absorbent diaper that soaks up, well, and keeps them dry. It's not glamorous, but it beats the alternative of ruining your $10 million spacesuit. So next time you see those heroic spacewalk photos, remember, even astronauts deal with some pretty basic bodily realities to boldly go where no one has gone before. The moon, a quick stop at our cosmic backyard. Leaving the ISS, let's venture further out to the moon. It's our nearest cosmic neighbor and loyal companion, orbiting Earth at about 239,000 miles away, 384,000 kilometers. That distance is hard to picture. So here's a fun way. If you drove to the moon at highway speed, say 60 miles per hour, it would take almost 6 months of non-stop driving. You'd definitely need a few snack breaks. The Apollo astronauts took about 3 days in a speedy rocket to get there. When they did, they made history, and they also made some unusual observations. For instance, the sky is always black on the moon, even when the sun is shining. With no atmosphere, there's no blue sky. It's daytime, the sun is out, but the sky is black as night. Spooky cool. One of the iconic things the Apollo astronauts did, besides the whole giant leap thing, was a simple physics experiment. They dropped a hammer and a feather at the same time. On Earth, the feather flutters down slowly due to air resistance. On the moon, no air, no resistance. A feather falls just as fast as a hammer. Apollo 15 astronaut David Scott performed this live on TV for a bit of Galileo drama. He let go of a geologist's hammer and a falcon feather together. Lo and behold, they hit the ground simultaneously. In the lunar vacuum, gravity affects all objects equally, and without air to slow the feather, it fell like a hammer. Galileo was right, and somewhere he high-fived Newton in science heaven. It's a surreal sight, and it confirmed a basic law of physics beyond Earth. Also, kudos to NASA for packing a feather in their luggage just for this moment. That's planning. The moon is also like a museum of history because it's covered in footprints and tire tracks from the Apollo missions. And there's no wind or rain to wipe them away. Neil Armstrong's one small step footprint from 1969 is probably still there, perfectly preserved. In fact, without erosion, those prints could last millions of years. Talk about not cleaning up after yourself. The only things that might disturb them are micrometeorites or a future astronaut accidentally stomping on them. So far, they remain as a monument to human exploration and extremely durable boots. Let's not forget, the moon is slowly saying bye Felicia to Earth. It's drifting away by about 1.5 inches, 4 centimeters per year. Tiny, but over time it adds up. In about 500 million years, the moon will be far enough that total solar eclipses won't happen anymore. The moon won't appear big enough to cover the sun. So enjoy those eclipses while you can. You have a few 100 million years, no rush. Why is the moon drifting? Tidal interactions. Basically, Earth's oceans tug on the moon and vice versa, and it imparts a little energy that boosts the moon's orbit. Don't worry, the moon isn't leaving us for good, it's just finding a new apartment slightly farther out. Fun fact, 12 humans have walked on the moon and they left more than footprints. They left gear, rover cars, and bags of poop. Yes, in the interest of weight savings for moon rocks, astronauts dumped their used waste bags on the moon. So technically, the moon is not only our first off-world visit, it's also humanity's first extraterrestrial landfill. One day, future scientists might study those artifacts. Let's hope they have good gloves. The weird and wonderful solar system. Buckle up, because now we're zooming off to explore the solar system, a neighborhood filled with planets that are stranger than fiction. Each one has its own personality and issues. We've got 8 planets now. Pluto, we still love you, but you're in the dwarf planet club. In 2006, Pluto was officially reclassified as a dwarf planet by astronomers, which broke many hearts. It's okay, Pluto has a heart-shaped glacier, visible in New Horizons probe photos, to show it still loves us back. Mercury, the fast but freezing hot planet. First stop from the sun is Mercury, a little speed demon. Mercury is the smallest planet and whips around the sun in just 88 days. A Mercury year, one orbit, is 88 Earth days. But Mercury rotates slowly. One Mercury day, sunrise to sunrise, is about 176 Earth days. So a day on Mercury actually lasts 2 Mercury years. Confusing, right? Mercury is like that friend who's always running around, fast orbit, but is slow to get out of bed, slow rotation. It's also a planet of extremes. When the sun is up, the surface scorches to about 800 degrees Fahrenheit, 430 degrees Celsius. When the sun sets, it plunges to 290 degrees Fahrenheit, 180 degrees. Mercury has virtually no atmosphere to blanket or distribute heat, so it's an icy furnace, if that makes sense. No atmosphere also means craters everywhere. It looks like our moon. Mercury is basically a rock that's too close to a bonfire on one side and in deep freeze on the other. Visit at your own risk and pack both sunscreen and a parka. Venus, Earth's evil twin with a crazy day length. Next, we meet Venus, often called Earth's sister planet, same size, but frankly, it's more like Earth's evil twin. Venus is scorching hot, even hotter than Mercury, despite being farther from the sun. Its thick CO2 atmosphere creates a runaway greenhouse effect that traps heat. The surface of Venus averages around 864 degrees Fahrenheit, 62 degrees Celsius, hot enough to melt lead. So, no summer homes on Venus unless you like your vacation spots to vaporize your spaceship. Not only that, the pressure at the surface is about 90 times Earth's, equivalent to being 900 meters, about 3,000 feet underwater. If you stood on Venus, please don't, you'd be crushed by the pressure and broiled by the heat and dissolved by clouds of sulfuric acid. Yikes. Venus is basically a giant pressure cooker with acid rain, clearly in a bad mood. But as if Venus wasn't weird enough, check this out. A day on Venus is longer than a year on Venus. Yes, you heard right. Venus takes about 243 Earth days to rotate once. That's its day length, and about 224.7 Earth days to orbit the Sun, year length. So a Venusian day lasts a little longer than its year. Imagine living there. You'd celebrate your birthday, one orbit, before you finish one Venus day at work. Talk about a long workday. Also, Venus spins backwards, retrograde rotation, compared to most planets, so on Venus the sun rises in the west and sets in the east. Basically, Venus marches to the beat of its own drum. It's like that rebellious goth cousin of Earth, similar in size and composition, but whoa, very different lifestyle. Earth, the Goldilocks world. Now we arrive at Earth, but you already know this one. It's the only planet we know teems with life, at least for now. It's got liquid water, a nice breathable atmosphere, a protective magnetic field, and Netflix. Truly the Goldilocks planet. Not too hot, not too cold, just right most of the time. Let's pat ourselves on the back for Earth's awesomeness, but also remember that from space, Earth is just one of many. We're special, but the universe didn't necessarily save the best for first. There could be other Earth-like havens out there. While we're here, a neat fact about our sun, since Earth orbits it: sunlight takes about 8 minutes 20 seconds to reach Earth. That means every time you feel the sun's warmth, you're feeling photons that left the sun 8 minutes ago. If the sun hypothetically turned off, don't worry, it won't anytime soon. We'd have 8 minutes of ignorance before darkness hit. And it's not just light. If the sun vanished, Earth would keep orbiting nothing for those same 8 minutes, because gravity waves travel at light speed too. So, there's always an 8-minute delay in our conversation with the sun. In a sense, we're seeing the sun as it was minutes in the past. Spooky, but also useful. Knowing the speed of light gives us a cosmic yardstick for distances. We measure things in light years. The distance light travels in 1 year, 5.88 trillion miles or 9.46 trillion kilometers. 1 light year is far. If you drove to Proxima Centauri, the nearest star, at highway speed, you'd get there in 50 million years. Flying by jet? Still 5 million years. Even a fast spaceship like Voyager would need 70,000 plus years to reach it. Space is big. We'll get to just how big later. Okay, back to our tour. Mars, the rusty red wanderer. Next stop. Mars, the red planet, named for the god of war, perhaps because of its blood-reddish color. Mars is a perennial favorite in sci-fi and of space agencies eyeing future human missions. It's cold, dusty, and much smaller than Earth, about half Earth's diameter. If you weigh 150 pounds on Earth, you'd weigh only about 57 pounds on Mars. Its gravity is 38% of Earth's. Good for jumping around. You'd be able to bounce about 3 times higher. Mars has some record-breaking features. Olympus Mons, the largest volcano and mountain in the entire solar system, towers about 16 miles, 25 kilometers high. That's roughly 3 times taller than Mount Everest. It's so wide, as big as the state of Arizona, that if you stood on Olympus Mons, the slope is so gentle, you might not realize you're on a mountain. The horizon would just gradually fall away. Mars also has a canyon named Valles Marineris that's over 2,500 miles long and up to 7 miles deep. It would stretch across the United States. Basically, Mars went big on geology. Mars is often called the red planet because its soil is rich in iron oxide, rust. If you've seen pictures, it's a butterscotch or orangey red color everywhere. It also has polar ice caps made of CO2 ice and water ice that grow and shrink with the seasons. Mars's atmosphere is very thin, about 1% of Earth's pressure, mostly CO2, so it won't breathe for you. Temperatures vary widely from a comfortable 70 degrees Fahrenheit to at noon near the equator in summer, down to 100 degrees Fahrenheit and 73 degrees or lower at night. Mars can have dust storms that engulf the whole planet for weeks. Imagine a global dust hurricane. Good times. We've been exploring Mars with robots for decades. Rovers like Curiosity and Perseverance are basically our mechanical stand-ins, rolling across the Martian desert, snapping selfies and doing science. Curiosity even played a little tune on its first birthday on Mars. It sang Happy Birthday to itself in 2013 using its sample analysis instrument vibrating at musical tones. That might be the loneliest birthday party ever, one robot singing alone on a distant planet. The rovers have found evidence that Mars long ago had liquid water on the surface, rivers, lakes, maybe an ocean. Nowadays, any water is mostly frozen underground. But who knows, maybe microbial life once swam in Martian ponds. We haven't found Martians yet, but we're still looking for signs of past life. At the very least, Mars is probably humanity's next destination for boots on the ground. Plans are underway, optimism is high, and perhaps the first astronaut to walk on Mars is already born among us, training for the big day. Jupiter, king of the planets, and its monster storm. After the inner rocky planets comes the realm of giants. Jupiter is next, and everything about Jupiter is supersized. It's the largest planet in our solar system by far, so big that over 1,300 Earths could fit inside it. It's basically a colossal ball of hydrogen and helium gas with some other stuff mixed in. We call it a gas giant for a reason. If the Sun is the father of the solar system, Jupiter is the hefty uncle who could shoulder all the kids. In fact, Jupiter is more massive than all the other planets combined, except the Sun, of course. One look at Jupiter through a telescope, and you'll notice its gorgeous cloud bands and the famous Great Red Spot. That red spot is not a pimple. It's a giant storm, a hurricane-like high-pressure system that's been raging on Jupiter for at least hundreds of years. Astronomers in the 1800s documented a big red spot, and it's still there, though it's been shrinking a bit lately. Currently, the Great Red Spot is about 10,000 miles across, roughly 1.3 times the width of Earth. In the late 1800s, it was estimated at 2 to 3 times Earth's width, so it's gotten smaller, but it's still gigantic. Wind speeds in that storm reach hundreds of miles per hour. Basically, Jupiter has an everlasting mega hurricane. And here we get nervous about week-long Earth hurricanes. On Jupiter, storm of the century has been going since before the US Civil War. Jupiter spins extremely fast. One day on Jupiter is only about 10 hours. That rapid rotation flattens Jupiter slightly. It bulges at the equator and stirs up those stripes. It also means if you tried to stand on Jupiter, there's no solid surface, so good luck. You'd be flung around unbelievably quickly. Jupiter's atmosphere is mostly hydrogen and helium, so it's like a star that didn't quite make it to stardom. If it were about 80 times more massive, it could have ignited fusion and become a second sun. Thankfully it didn't, or we might not be here. That would have messed up the solar system big time. Now, Jupiter doesn't come alone. It's basically a mini solar system. It has dozens of moons, at least 79 moons at last count. 4 of them are big enough to be really interesting, called the Galilean moons, because Galileo discovered them in 1610 with his telescope, shocking the world that not everything orbits Earth. There's Io, volcano world, literally covered in active sulfur volcanoes, a moon that's constantly erupting lava, thanks to Jupiter's tidal squeezing. There's Europa, an ice-crusted moon with a possible ocean beneath, a top candidate in the search for alien life in our solar system. Ganymede is next, which is actually the largest moon in the entire solar system. Even bigger than Mercury, Ganymede is so large, roughly 3,270 miles in diameter, that if it orbited the Sun rather than Jupiter, we'd call it a planet. And then Callisto, a heavily cratered ancient moon. Each of these moons could warrant their own story. Jupiter basically is the landlord of a lot of fascinating tenets. One more cool tidbit: Jupiter has rings too. They're faint and were discovered by spacecraft, not nearly as grand as Saturn's. But yep, even Jupiter has a diadem. Saturn, Lord of the Rings and low-density shenanigans. Onward to Saturn, the second largest planet and arguably the prettiest. Those rings. If planets competed in a beauty pageant, Saturn would waltz away with the crown. Its rings are broad and bright, made of countless chunks of ice and rock ranging from pebbles to boulders, all orbiting Saturn's equator in a flat disk. They might look solid from afar, but if you got close you'd see it's like a cosmic ice donut. Particles everywhere but lots of space between them. Saturn's rings are only maybe 30 feet thick in some places, yet span hundreds of thousands of miles in diameter. They might be remnants of a shattered moon or comet that wandered too close eons ago. Whatever their origin, they give Saturn a flair that's instantly recognizable. Saturn itself is a gas giant like Jupiter, mostly hydrogen and helium. It's famous for being extremely low density. In fact, Saturn's average density is about 0.69 grams per cubic centimeter, which is less than water. You often hear the fun trivia: Saturn could float in a giant bathtub. It's true in principle. If you had a bathtub big enough, we're talking enormous, and hopefully you paid your water bill, Saturn would bob around like a colossal rubber ducky. Of course, Saturn is not solid, and if you try to dip it in water, it would probably just break apart. But as a thought experiment, it's neat. It's the only planet lighter than water. All others would sink. So Saturn is the lightweight champ of the solar system. A day on Saturn is about 10.7 hours, pretty fast spin, and a year on Saturn is about 29.5 Earth years. Saturn has a ton of moons as well, at least 83 known. The largest, Titan, is extremely cool. It's bigger than Mercury and has a thick nitrogen atmosphere, the only moon with a substantial atmosphere. On Titan, it actually rains liquid methane and has rivers and lakes of methane, ethane. It's like a bizarro Earth. Similar processes: rain, erosion, rivers, but with cryogenic hydrocarbons instead of water. If there's a second place for most likely to have life after Earth, Titan is often in the conversation. Maybe some weird methane-based life. Another moon, Enceladus, is a tiny ice ball that's shooting out geysers of water from a subsurface ocean. We literally sampled those geysers by flying the Cassini spacecraft through them, finding hints of organic compounds. Saturn's moons are full of surprises. And a special mention, Saturn's North Pole has a strange hexagon-shaped storm in its atmosphere, a six-sided jet stream pattern. Nature loves to be weird. Uranus, the tilted oddball. Continuing outward, we reach Uranus. Okay, first, it's pronounced Uranus or Uranus. Pick your poison. Either way, it's hard to not giggle. We'll call it the sideways planet because it's literally tilted on its side. Uranus's axis is tilted by about 98 degrees, meaning it basically rolls around the Sun on its side like a barrel. This is likely due to a massive collision long ago that knocked it over. What does that mean? It means Uranus has crazy seasons. Each pole gets 42 years of continuous sunlight, followed by 42 years of darkness, because it takes 84 Earth years to orbit the Sun. Imagine a 42-year-long day, then a 42-year-long night. The equator gets weird spring-fall transitions where the Sun rises and sets almost around the horizon daily, while the poles are half the time sunlit, half darkness. It's a very alien concept of seasons. Uranus is an ice giant composed mostly of water, methane, and ammonia ices, slushy mix, above a small rocky core. It has a pale blue-green color due to methane gas in the atmosphere, absorbing red light and reflecting blue. Through a telescope, Uranus doesn't have a lot of obvious features. It's a relatively bland bluish disk. But spacecraft, Voyager 2 in 1986, found it has faint rings and a magnetic field oddly offset from its center and tilted from its axis. Like everything about Uranus is tilted or off-kilter. An interesting thing about Uranus, at solstice, one pole faces the Sun continuously, so half the planet gets constant daylight, the other constant night. At equinox, the Sun rises and sets around the equator rapidly. It's just so weird compared to any other planet's orientation. Also, Uranus is cold. It's the coldest planetary atmosphere in the solar system at cloud top, minus 300 degrees Fahrenheit, right, 220 degrees. Even though Neptune is farther, Uranus somehow has colder temps in places. It's like Uranus said, I'm already weird, might as well be extra cold too. And yes, scientists have discovered that Uranus likely has a layer where it might rain diamonds deep in the interior. This applies to Neptune too. High pressure can break methane into carbon, which then crystallizes into diamonds that rain down toward the core. Literal diamond rain. This might be happening in the unseen depths of Uranus. If you could collect them, you'd be rich, and also dead from the crushing pressure and temperature, minor detail. Neptune, the windy blue world. Finally, we reach Neptune, the outermost planet, since poor Pluto got demoted. Neptune is a gorgeous deep blue color, even richer blue than Uranus, due to methane and perhaps some unknown atmospheric components. It's an ice giant like Uranus, similar size, 4 times Earth's diameter, and orbits the Sun every 165 years. Since its discovery in 1846, it's completed just one orbit in 2011. Neptune is a dynamic place. It has the fastest winds in the solar system. Winds have been clocked at 1,200 to 1,500 miles per hour, about 2,000 plus kilometers per hour in its atmosphere. For comparison, the strongest hurricanes on Earth maybe hit 200 miles per hour gusts. Neptune laughs at that. Its winds are supersonic relative to Earth's sea level speed of sound. Why such insane winds? Possibly due to internal heat and the lack of a solid surface to slow things down, plus complex atmospheric dynamics. Neptune had a great dark spot, like Jupiter's red spot, but dark and not as long-lived, observed by Voyager 2 in 1989, which later disappeared, and new dark spots have since been seen by Hubble. So Neptune has big storms too, but they come and go. It's like a more active, stormy cousin of Uranus. Neptune has 14 known moons, the largest being Triton. Triton is peculiar. It orbits Neptune backwards, retrograde orbit, and is likely a captured Kuiper Belt object, basically a Pluto-like world snared by Neptune's gravity. Triton has geysers, erupting nitrogen gas, and a thin atmosphere. It's one of the coldest places measured in the solar system, around minus 391 degrees Fahrenheit, minus 235 degrees Celsius. If Neptune weren't around, Triton might have orbited the Sun as an independent dwarf planet. Like Uranus, Neptune's interior might also have the exotic diamond rain phenomenon going on. It's a wild thought that these distant planets could have literal gemstones forming and falling deep inside. One more thing, both Uranus and Neptune appear to have a bluish color thanks to methane, which absorbs red light and reflects blue. If you could see them up close, they're like beautiful azure orbs. Neptune especially is a deep royal blue. If Earth is the pale blue dot, Neptune is the bold blue orb. And beyond Neptune, we enter the domain of icy dwarfs like Pluto, Eris, Makemake, Haumea, the Kuiper Belt of countless frozen mini-worlds. But if we start on Pluto, we might be here all day. Pluto has its own heart-shaped region, and mountains of ice, and even an atmosphere that freezes onto the ground when it's at aphelion. So cool, but we'll save it for another time. Before we leave the solar system, let's mention one fun fact. Saturn isn't the only one with rings. Jupiter, Uranus, and Neptune have rings too, just faint ones. And Mars has 2 tiny moons, Phobos and Deimos, that might be captured asteroids. Earth, of course, just has the one big moon, but it's relatively huge for a planet our size, a real odd couple. Our moon likely formed from a giant impact early in Earth's history. Earth literally got smacked by something Mars-sized, and the debris formed the moon. The solar system's early days were wild. We're lucky now it's a bit calmer. No planet-sized smackdowns lately, fingers crossed. Journey to the stars. We've toured the Sun's family, but as amazing as our planets are, they're just one star's entourage. Our Sun is one of about 100 to 400 billion stars in the Milky Way galaxy. So now let's venture farther out, to the realm of stars. First, our Sun. It's a fairly average star, a G-type main sequence star, if you want to sound fancy. It's about 864,000 miles across, 1.39 million kilometers, and contains 99.8% of all the mass in the solar system. Jupiter has most of the rest. The Sun is basically a giant nuclear fusion reactor, turning about 600 million tons of hydrogen into helium every second, and releasing energy that keeps us warm and alive. Inside the Sun, the core is 27 million grosmours. The energy produced in the core takes a long random walk out to the surface, sometimes tens of thousands of years to get out, bouncing around, then an 8-minute sprint to Earth as sunlight. How big is the Sun compared to Earth? We often hear we could fit about 1.3 million Earths inside the Sun, if it were hollow and you packed them in. It's 109 times Earth's diameter. To help visualize, if the Sun were the size of a basketball, about 23 centimeters diameter, Earth would be a little 2 millimeters bead about 25 meters away, roughly half a football field's length away. Tiny Earth. Big distances. Neptune in that model would be an ant-sized speck 2 football fields away. The solar system is mostly space, empty space, with these little islands, planets, scattered far apart. Remember our car analogy. Space is only an hour up, but to drive to the outer planets would take hundreds or thousands of years. There's a reason we use spaceships and gravity assists and not road maps. Beyond the Sun, stars come in a huge variety. Some are much smaller than our Sun, red dwarfs, which are dim and cool and can burn for trillions of years. Others are massively larger. The current record holder we know of is jwst, a red supergiant star. It's estimated to be at 1,700 times the Sun's diameter. If you plopped jwst where our Sun is, it would reach out near Saturn's orbit. That one star could engulf the first 6 planets. It could fit 5 quadrillion, 5,000 trillion Earths inside it. These numbers are mind-numbing. jwst makes the Sun look like a pea next to a beach ball. And yet, even jwst isn't infinite. There may be bigger stars out there, but they're relatively rare. On the other end, there are neutron stars, which are the collapsed cores of massive stars that went supernova. A neutron star packs more mass than the Sun into a sphere only about 12 miles across. 1 teaspoon of neutron star material would weigh billions of tons on Earth, roughly like a Mount Everest's worth of mass in a spoon. That's the kind of crazy extremes nature can produce. And if you actually held that teaspoon, you'd be instantly crushed, or rather it would fall through the Earth, but let's not try that. Our closest star aside from the Sun is Proxima Centauri, part of the Alpha Centauri system, about 4.24 light-years away. A light-year is 5.9 trillion miles, so that's roughly 25 trillion miles, 40 trillion kilometers. Remember how fast light is, zipping around Earth 7.5 times a second, yet it still takes over 4 years to go to the nearest star. So the stars are really spread out. If the Sun were a basketball in New York, the nearest star on that scale might be another basketball in Los Angeles, roughly. Space is spacious. Our fastest spacecraft, Voyager 1, which is currently over 15 billion miles away from Earth, that's over 160 astronomical units, where 1 AU is Earth-Sun distance, took 45-plus years to get that far since 1977. And it's just barely outside the solar system's main plasma bubble, heliosphere, but not yet near any other star. If heading toward Proxima, it'd need tens of thousands of years, as we mentioned. So as much as sci-fi loves warp drives and hyperspace, with today's tech, the stars are essentially unreachable in human lifetimes. The distances are quite literally astronomical. The Milky Way and beyond, all the stars you see in the night sky, those twinkling dots, are part of our Milky Way galaxy, a huge spiral galaxy containing perhaps 100 billion or more stars. It's a barred spiral about 100,000 light-years across. That's the disk diameter, from one edge of the spiral to the other. We live not in the center, good, because there's a nasty huge black hole and lots of radiation there, but out in a spiral arm, like living in the suburbs of the galaxy. Specifically, we're in the Orion arm or spur of the Milky Way, about 26,000 light-years from the center. The center of our galaxy hosts a supermassive black hole named Sagittarius A Star, pronounced A-star. It's about 4 million times the mass of the Sun. Normally black holes are tiny for their mass, but 4 million suns is still enormous, though within a volume smaller than our solar system. We can't see it, black hole, duh. But we observe stars whipping around an invisible spot at incredible speeds, which is how we know its mass. Occasionally it snacks on gas or asteroids and burps out X-rays. It's relatively quiet as far as cosmic monsters go. Many galaxies have giant black holes in their cores. If we could view the Milky Way from outside, it would look like a flat disk with spiral arms. sort of like a cosmic frisbee with swirly patterns. When we look up at the night sky on a clear night from a dark location, the Milky Way appears as a milky band of light. That's the disk of our galaxy seen edge on from within. Those tiny stars you see? Many are like the sun, some bigger, some smaller. Statistically, most are red dwarfs, small, dim. A lot of them likely have planets. In fact, as of now, we've confirmed over 5,000 exoplanets, planets around other stars, and that's just scratching the surface. There are likely hundreds of billions of planets in our galaxy alone. We've found hot Jupiters, super-Earths, even planets in habitable zones where liquid water could exist. The more we look, the more we realize planets are common. The odds that none of those billions of planets have life? Well, it would be astonishing if we were truly the only ones. Though as of today, we still have 0 confirmed ET life. The universe is probably teeming with life, or we're a rare fluke. Either way is mind-blowing. The Milky Way is just one galaxy. Our nearest big galaxy neighbor is Andromeda, about 2.5 million light-years away. That means the light we see from Andromeda left it 2.5 million years ago, when early humans were just figuring out stone tools. Every galaxy is like an island universe with millions or billions of stars. Hubble's Space Telescope famously pointed at a seemingly empty dark patch of sky for 11 days and collected faint light. The result was the Hubble Ultra Deep Field, an image showing about 10,000 galaxies in that tiny patch of sky. To understand how small a patch, they said it's like the area of sky covered by a grain of sand, held at arm's length. Imagine that. In a sand grain-sized darkness, 10,000 galaxies revealed themselves. Each galaxy with billions of stars, each star maybe with planets. Our observable universe, the part we can see, limited by the speed of light and the age of the universe, contains an estimated 100 billion galaxies. Some say up to 200 billion or more. And beyond that, potentially more universe that we can't see. Perhaps infinite. We don't know. So how many stars in the observable universe? Roughly 70 sextillion, 7 times 10^, that's 70,000 stars, a 23-digit number. Some clever folks compared it to sand. There are more stars in the universe than grains of sand on all Earth's beaches by a hefty margin. One estimate says for every grain of sand on Earth, there are 10,000 stars in the universe. That just defies comprehension. Next time you're at the beach, run a handful of sand through your fingers and imagine 10,000 stars for each grain. And each star could have planets, and some of those planets might have life? Suddenly, we don't feel so alone, or at least we feel very small in a vast cosmos. Galaxies themselves cluster and form webs. The Milky Way and Andromeda are in a small group, the local group. That's part of a bigger cluster, Virgo supercluster. And all the superclusters form this sponge-like structure on the largest scales, with filaments of galaxies and huge voids with few galaxies. It's like a cosmic foamy pattern. The universe is about 13.8 billion years old, but because it's been expanding, the edge of the observable universe is about 46 billion light-years away. That's how far the most distant galaxies we see are now. There's light reaching us now that left those galaxies over 13 billion years ago, not long after the first stars formed. The new James Webb Space Telescope, jwst, is actually seeing some of the earliest galaxies ever formed, over 13.5 billion years in the past. Basically baby galaxies after the Big Bang. Webb's first deep field image revealed thousands of galaxies in that tiny grain of sand patch of sky, including some whose light started traveling toward us when the universe was only a few 100 million years old. We are literally looking back in time when we gaze at distant galaxies. The cosmic history is laid out across space. Now, time for some exotic stuff. Black holes, neutron stars, supernovae. Oh my, we touched on neutron stars. Black holes are what you get if a really massive star dies or if you have a lot of mass in one place. They are regions where gravity is so intense, not even light can escape if it gets too close. Contrary to cartoon depictions, black holes don't go around like vacuum cleaners, sucking things up indiscriminately. You have to pretty much come within a certain distance, the event horizon, to be trapped. But if you do, bye-bye. You're not coming out. Tidal forces near a black hole can be extreme. The difference in gravity between your head and toes could be thousands of Gs. Literally pulling you into a spaghetti-like strand. The term is spaghettification, a fun word for a deadly process. Yet, black holes also might be responsible for some of the most energetic phenomena in the universe. Quasars, supermassive black holes actively devouring matter, blazing like beacons from across the universe. Then there are supernova, exploding stars. These are extremely luminous events. For a short time, a supernova can outshine an entire galaxy. They are also the factories of heavy elements. Elements heavier than iron, like gold, platinum, uranium, are made in the cataclysms of supernova and also collisions of neutron stars. Every atom of gold in your jewelry was forged in a stellar explosion eons ago and thrown into space, later to coalesce in our solar nebula and become part of Earth. Think about that next time you look at a gold ring. It's star debris from a cosmic blast. In fact, most of the elements in your body were made in stars. The carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood. All those atoms were fused in the core of stars that lived and died before our sun was born. We are made of star stuff, as Carl Sagan said. It's literally true. The early universe had only hydrogen and helium, and a bit of lithium. It took generations of stars living and dying to build up the heavier elements. Those elements got incorporated into new star systems, like ours. So in a very real sense, we carry the legacy of ancient stars within us. We are a way for the universe to know itself, as Sagan poetically put it. The atoms in your body have existed for billions of years, cycling through various forms. Gas clouds, stars, planets, maybe other life. And now they're you. Eventually they'll disperse again into the Earth or atmosphere, maybe someday becoming part of something else. We're part of this grand cosmic recycling program. Every one of us is literally stardust, forged in the fiery hearts of distant suns and blown across the galaxy by supernova winds. How's that for special? Final thoughts. Space is big, you are stardust, and exploration awaits. As our journey winds down, let's try to wrap our heads around what we've seen. We started on our comfy Earth, flung ourselves out past the moon, the planets, and into the staggering scale of the galaxy and universe. It's a huge, old, and astonishing universe out there. It's humbling and inspiring all at once. Feeling small is natural. We are on a tiny rock orbiting a medium star in a vast sea of stars. But also consider, out of that vastness, we emerged. We are a part of this universe, and we can understand a great deal of it through science and curiosity. We've sent probes to every planet, walked on the moon, peered to the edge of the observable cosmos with our telescopes. Not bad for clever primates with a penchant for problem-solving and storytelling. Let's not forget some of the downright fun and bizarre things we learned along the way. Astronauts wear space diapers, and space can smell like burnt steak. A day on Venus is longer than its year, and it rotates backwards. On Mars, robots sang happy birthday to themselves in lonely celebration. Jupiter's great red spot could swallow Earth whole and has been raging for centuries. Saturn could float in water, if you had a tub big enough, and dazzles us with rings. Uranus is sideways, perhaps doing the biggest cosmic, look at me, I'm different act. Neptune has winds faster than the speed of sound on Earth, and probably rains diamonds deep down. And out beyond, nearly every star you see has its own family of planets. Some of those planets are downright crazy. We discovered one, jwst 9733b, that likely rains molten glass sideways in 5,000 mph winds. Imagine blue skies with shards of glass flitting about, beautiful but deadly. Another, WASP 76b, is so hot it has iron rain. Iron vaporizes on the day side, blows to the night side, and falls as molten iron droplets. The universe is wildly creative in making worlds. Reality one-ups fiction at every turn. Now, given the immensity of all this, one could feel insignificant. But think of it another way. We're fortunate. Out of the cosmic lottery, we got a ticket to existence. We get to witness and learn about this spectacular universe. We've even begun to venture beyond our cradle. As Voyager 1 drifts farther into the darkness, its golden record remains a beautiful symbol of hope, a time capsule from a tiny planet orbiting a rather ordinary star. Think about it. In a cosmos that's nearly 14 billion years old and unimaginably vast, we've launched a physical object that quietly whispers, "We were here. We wanted to say hi." And Voyager isn't alone. Its twin, Voyager 2, launched just a few weeks earlier, is also on a similar escape trajectory, carrying its own golden record. These spacecraft were never expected to last this long, and yet, over 45 years later, they're still sending faint signals back to Earth. In fact, the faintness of that signal is astonishing. Less than a billionth of a watt reaches our antennas. And yet, from that whisper in the void, scientists can extract information about temperature, particle density, and the structure of interstellar space. That's the power of human ingenuity. But it's not just about distant spacecraft. Closer to home, we've built an infrastructure in space that past generations could only dream of. The International Space Station orbits Earth every 90 minutes, a multinational science lab floating in microgravity. New satellites are launched almost weekly, monitoring the climate, enabling global communication, mapping our planet with astonishing precision. Space has become a vital part of our civilization's nervous system. And still, we look further. Mars has become our robotic playground. From spirit and opportunity to curiosity and perseverance, our rovers are crawling across the red sands, drilling into rocks and scanning for signs of ancient life. One even brought a mini helicopter, Ingenuity, which became the first aircraft to fly on another planet. An incredible milestone in our species' history of exploration. Then there's Europa and Enceladus, icy moons of Jupiter and Saturn, respectively, believed to harbor subsurface oceans. Enceladus even sprays water vapor through its icy crust, creating natural fountains in space. We've flown probes through these plumes, detecting organic molecules, the building blocks of life. If life exists in our solar system beyond Earth, these oceans are excellent places to look. What's next? We are on the cusp of returning to the moon. Through NASA's Artemis program, humans will soon walk on the lunar surface again, not just to leave footprints, but to build a sustained presence. This time we're planning to stay longer. The moon could become a stepping stone, a training ground for missions farther out, a launch pad to Mars perhaps, or a place to mine water ice for fuel. Private companies like SpaceX, Blue Origin, and others are radically reshaping how we access space. Reusable rockets are lowering costs and increasing launch frequency. There's real talk, not just science fiction, about humans setting foot on Mars within a couple of decades. And unlike Apollo, the goal now is not a quick visit, but the beginnings of a permanent settlement. It sounds bold, maybe even reckless, but history suggests that exploration is part of our nature. We crossed oceans and continents long before we understood maps. Now we cross space with rockets instead of ships, curiosity instead of compasses. But here's the big question. Why? Why send machines or people to faraway hostile places? Why spend time and resources on space when we have so many problems on Earth? The answer, in part, is that exploration inspires solutions. Technologies developed for space have improved life here. Satellite weather forecasting, GPS, advanced materials, medical imaging, water filtration, and much more. The challenges of space demand innovation, and those innovations ripple into every corner of society. But there's a deeper reason too. Space is a mirror. When we look outward, towards stars, planets, galaxies, we also reflect inward. We begin to ask questions, not just about what's out there, but about who we are. Where did we come from? What is our place in the grand cosmic story? Are we alone? These questions have stirred humanity for millennia. And for the first time in history, we may be close to answering some of them, scientifically. With new telescopes like jwst, James Webb Space Telescope, and future missions like LUVOIR or HabEx, we may soon detect the chemical signatures of life on exoplanets. Oxygen, methane, or other biosignatures in alien atmospheres. Imagine the headline, "Life detected on planet 47 light-years away." That moment will be epochal. Not just a scientific revelation, but a cultural and philosophical turning point. We will know we are not alone. And yet, even if we find no one, if the cosmos is quiet, lifeless except for us, that too is powerful. It would mean that life is incredibly rare and precious. That Earth is not just our home, but the only home for now. That we carry the flame of consciousness in a vast silent night. In either case, the responsibility is enormous. As we spread our reach beyond Earth, we will carry more than machines and data. We will carry our values. How we treat one another, how we care for our home planet, how we interact with any life we might find, these will define our legacy in the universe. Because space is not just about escape, it's about connection. Connection to each other, as passengers on the same tiny world. Connection to the stars, which birthed our atoms. Connection to the future, which we are building, rocket by rocket, question by question. So when you look up at the night sky, remember that we are not just spectators. We are participants in this grand cosmic unfolding. We are the species that wonders, builds, questions, reaches, and one day perhaps becomes a spacefaring civilization. Not to flee Earth, but to honor it. Not to conquer worlds, but to understand them. And not to find others who are like us, but to celebrate the diversity of what life and intelligence might become. The International Space Station has been continuously inhabited for over 20 years now. There are people living off Earth right now. Plans are in motion to return to the Moon, the Artemis program, and to set foot on Mars in the coming decades. Private companies are launching rockets, even sending a sports car to orbit the Sun. Remember the Tesla Roadster with Starman, dummy? It's out there in an elliptical orbit around the Sun, jamming to David Bowie. So space isn't just science and cold facts. It's also human dreams. It's a place of adventure, mystery, and infinite questions. Are we alone? How did it all begin? What's the fate of the universe? Will we travel to the stars someday? These questions keep us looking upward. When you go out on a clear night and stare at the stars, remember, you're seeing ancient light. Some of those pinpricks might have died out, and we're seeing their ghost from years ago. You're also literally bathing in the stuff of galaxies. Photons that have crisscrossed space for eons end their journey on your retina, triggering an image in your brain. In a way, the universe is reaching out to you, telling its story through that starlight. Our journey has shown that space can be fun, crazy, and awe-inspiring all at once. We laughed at some of its absurdities. Space has a sense of humor, clearly. Diamond rain, sideways planets? Come on. We marveled at its grandeur. We grounded ourselves in the knowledge that we belong. We're made of star stuff, we're exploring our cosmic neighborhood, and our curiosity is as infinite as the universe itself. So the next time you gaze up or watch a sci-fi flick or read a space article, I hope you carry a bit of that childlike wonder mixed with understanding. Space is not just something out there. We're part of it. We're at home in the universe, even as we struggle to comprehend it. And that, my friends, is both comforting and exhilarating. In conclusion, space is big, ridiculously big. It's beautiful, bizarre, and full of surprises. We've taken a whirlwind tour from our earthly vantage point to the edge of the observable universe, with stops at planets, stars, and galaxies in between. And we did it with a smile, because learning about the cosmos doesn't have to feel like a lecture. It can feel like an adventure or a late-night chat with a friend under the stars. Stay curious, keep looking up, and remember, the universe is always ready to tell you a new story. After all, we're made of its stories. We are the universe, talking about itself. How cool is that? Thank you for joining this cosmic ride. Safe travels, fellow star stuff.